the wood frog. The only amphibian capable of stopping its own heart and coming back to life. This species, Rana sylvatica, is capable of modifying its metabolism in order to survive temperatures as low as -18 degrees Celsius. In the next 10 minutes, we will dive deep into the intermediary metabolism of this astonishing species. We will see the frog undergo changes before, during, and after cryoprotective conditions. Under normal conditions, the wood frog, like any other amphibian, catches flies and jumps from lily pad to lily pad. Its life may seem simple, but if we take a deeper look, we find its metabolic processes are intricately regulated to maintain homeostasis. During this state, when available, the frog uses oxygen for aerobic respiration. The frog relies on lipid fuel during rest, carbohydrates under more strenuous conditions. Here, we can see the wild woodland beauty catching its prey. To better understand how frog metabolism differs from the cryoprotective state, we must first comprehend the metabolic processes in the normal condition. The beginning of aerobic respiration starts with glycolysis, the breakdown of sugar molecules. The first step in breaking down glucose is catalyzed by hexokinase, resulting in glucose 6-phosphate and the consumption of 1 ATP molecule. The second reaction uses phosphoglucose isomerase to commence the conversion of G6P to fructose 6-phosphate. Subsequently, F6P is the substrate for the enzyme phosphofructokinase, which produces fructose 1,6-bisphosphate. Here, we see the division of the 6-carbon compound F1,6BP into the 3-carbon molecule 1,3-bisphosphoglycerate by the enzyme glyceraldehyde 3-phosphate dehydrogenase. This compound goes on to be partially oxidized in the form of 2 pyruvate molecules. Other molecules that are used for energy production, such as ATP and NADH, are yielded from glycolysis. When oxygen is present as the final acceptor, pyruvate is passed into the TCA cycle and the electron transport chain. This process yields a substantial amount of ATP, which fuels the frog's day-to-day activities, such as finding a mate to cuddle for the long, cold winter ahead. Excess glucose is stored as liver and muscle glycogen. The frog taps into these stores when blood glucose levels are low in the future. As the temperature begins to drop into the negatives, the wood frog begins to prepare itself for the process of cryoprotection. The frog's primary defense against the cold is to change its metabolic processes. Firstly, the frog retains its precious urine.
The metabolism of the wood frog is truly a fascinating specimen at its molecular level. Glycogen phosphorylase, an enzyme responsible for breaking down glycogen stores in the body, dramatically increases within the first few hours of freezing. Our research is focused specifically on the Alaskan wood frog. Our findings have shown that there is an increase of glycogen phosphorylase activity due to the fact that glucose is needed to act as a cryoprotectant in the bloodstream. The glucose and urine combine in the bloodstream to form a cryoprotectant. This cryoprotectant enters the cell and prevents it from dehydration. In the frog, respiration stops and begins to consist only of cutaneous gas exchange.
Thank you. Thank you all so much for having me here today. On behalf of the Canadian Institute of Enzymatic Metabolism for Amphibians, it's really an amazing opportunity to be here today speaking to you about such an important amphibian. Our work over the past few years has really consisted on focusing on Rana sylvatica, specifically Rana sylvatica's metabolism in its cryoprotective state. And what we found through our work at the Institute is that hexokinase activity is significantly decreased in the frozen state compared to control in its normal non-cryo protective state. This decrease in hexokinase activity can be explained by the fact that glucose is a cryoprotectant, and in order for Rana sylvatica's body to maintain that high level of glucose as a cryoprotectant, it needs to decrease glucose catabolism, thereby decreasing hexokinase activity. This increased reliance on anaerobic respiration, specifically through glycolysis, can be seen here, where we can see an increase in lactate accumulation in the frozen state of Rana sylvatica compared to the unfrozen state. Lactate is formed through a reduction of pyruvate to lactate through the enzyme lactate dehydrogenase.
Following several months of freezing temperatures and hibernation, spring has finally arrived. Only after a full 5-day period does the frog transition back to its normal metabolic activity and finally moves again.
The most fascinating portion of a frog's metabolism is not how it shuts its systems off, but how it is reborn from a lifeless state. Our lab's research focuses exclusively on the thawing portion after cryoprotection. The frog experiences a huge accumulation of lactate during cryoprotection that needs to be removed from the frog's muscle during thawing. The liver glycogen that is lost during freezing is replenished after only 5 days of thawing. This causes the liver glucose levels during this period to sharply reduce. Contrarily, the muscles, unlike the liver, dehydrate during freezing and are rehydrated within 48 hours of thawing. On a metabolic level, the frog slowly begins to rely on aerobic respiration again as respiration is restored and oxygen levels are increased. The glucose that was circulating the tissues as a cryoprotectant is then cleared by being broken down for energy, with any excess being stored as glycogen in the liver and the muscle. A substantial amount of ATP is needed in order to reactivate the frog's basic physiological functions, repair any freeze-induced damage, and restore the overall homeostasis of the frog. Therefore, PFK and GAPDH, which are two key enzymes in glycolysis, show significantly increased activity during thawing.
Now that spring has come, the wood frog has returned to its normal activities of eating flies and jumping on lily pads. The cryoprotection mechanism of the wood frog is an incredible feat of science that few creatures can accomplish. Being able to withstand snowy weather and icy storms, some might say that the wood frog is pretty cool.